Hello friends, in this video I will explain you how you can test different types of transistors. Okay, so let's start. So as you can see on your screen, for testing this these transistors I'm using a multimeter. Okay, so first of all I'm going to use this transistor. So this is BC547, okay, transistor. If you type in the Google, so you will get the details of BC547 transistor. Okay, so if you face, okay, so here two sides are there. One is plain surface, and other one is how curved surface. So if you face this transistor, means a plane surface of this transistor towards you, then the right side, okay, it is emitter, the middle it is a base, and the left side it is collector. You can get the details also from the internet. Okay, so how to test whether this transistor is okay or not? So for testing this transistor, I'm going to use this multimeter. So we will use the characteristic of transistor. Okay, so as you already know, base emitter junction of the transistor is forward bias. Okay, so if I forward bias the base emitter junction of this transistor, so then in that case it will show some value. So first of all you can select to the diode range also, or here continuity also. Okay, so first of all I'm going to use this continuity range. So middle one is the base, so and right one is the emitter. So emitter, and this is NPN transistor. Okay, this is NPN transistor. So NPN means the middle one, it is the positive, so NPN. So and the right side it is negative, NPN, N negative. So if I do, so middle one I connected to the red, and the right side I'm connecting, that is emitter, to black. So if I connect, so you will get some value. Okay, just the way we got in case of diode. Okay, so since this is forward bias, so in case of forward bias you will get some value. And if I reverse this, if I change this, okay, so if I change, right now I'm connecting red to the collector and black to the base, then in that case no value will come, just the way it was in case of diode. Okay, so if such type of thing is happening, then in that case this transistor is okay. And for short circuiting you can also check emitter and collector. If you connect, so no value should come. So if no value it is coming and no beep sound is coming, it means there is no short circuit in this transistor. Okay, this is short circuit test for this transistor, for in between the base and the collector. Sorry, base not, emitter and the collector. And another one, it was in between the base and emitter. So okay, so that it was forward bias of the base. Now this is the red one connected to the base, the middle terminal, and the black I'm connecting to the right terminal. Okay, so in that case some value it is going to come. Okay, in this way it is okay. In the same way we can use photo transistors also. So this is a photo transistor. So here how to identify. Now you can see here, if it is visible, then you can see, okay, there to the one side there is a notch. Okay, now here a type of notch is there. Now you can see here, there is a notch here this side. Okay, here it is a notch. So from there the place, the terminal where there is no, that is emitter. Okay, so the emitter, and then after the middle one it will be the base and the, okay, so if I face like this, then the right side terminal, here there is the notch, and then the middle one it will become the base, and the left side it will be the collector. Okay, so again the same process I can apply. So I'm going to use this multimeter, and this black one to the emitter and the red to the base. Okay, if I connect like this, then you can see on the screen of this multimeter some value will come, and if it is not coming, so it means this transistor is faulty. Okay, so in this way we can test, and for testing this BC547 transistor, again I'm going to use this here. Gain means how to check. Now you can see, as I already explained, this for this BC547, the right terminal is emitter, the middle one is base, and the left one is collector. So there on this multimeter you can see, so here you have to select to this HFE range. Okay, and then after you have to insert, now you can see here written ECB. Okay, so you have to insert emitter to the E, base to the P, and collector to C. Okay, so just the way I am doing here, I inserted. Okay, so as I'm going to, as I inserted, so you will get some value. Okay, so properly insert. Okay, when I properly insert, then you can see here it is coming 339. Okay, so 339 it's coming. So on the internet, so I got the data for this BC547. So now you can see on this mobile that BC547 here. For this BC547, now you can see, you can go to the specification. Now here it is. So DC current gain it is, that is HFE. Now you can see on this multimeter also there it is HFE DC, that is DC current gain. So is maximum it is 800. Okay, maximum it is 800, and the emitter voltage it is 6 volt, and means all different specification. Okay, according to what the circuit requirement, whatever type of specification it is required, you can get the value data from here. And what it is, the value it is coming 322. Okay, so right now, so now you can see transistor. Now BC547 transistor has a gain value of 110 to 800. It means in between 110 to 800 the value it may vary. So right now here it is coming around 320 or 21. Okay, in this way now we can test this transistor. Okay, the gain value of this transistor. Okay, so I explained different ways by which we can test transistor. Okay, so thank you all.